Hey everyone, welcome back to the Reactor Summer Series, or Winter Series as I like to call it, given that I am not based in a location that is currently experiencing summer, hence why I've got my hoodie on today. It's a little bit chilly here in Sydney, but that's all good. We're going to be learning more about the reliable web app patterns that we've been talking over the last couple of weeks about. You might have caught Justin's session last week, and Justin and I did a session a couple of weeks ago where we kind of introduced the topic that we'll be covering over these episodes. But today, the focus is going to be around security and what we have put in in terms of security when it comes to building reliable web apps for Azure and with .NET. But again, if today's the first episode you're joining, welcome. I'm glad you could join us for today's interesting talk about security. My name's Aaron Powell. I'm a cloud advocate at Microsoft on the .NET on Azure team, and I've been doing web development for nearly 20 years. If you want to reach out to me after the session, you'll find my social media and contact details there on the slides. But do feel free to ask questions in the chat. We're keeping an eye on that so that I'll do a bit of Q&A if anything comes up during the session towards the end. But without further ado, let's dive in and talk a bit about what we mean in the context of security here, because security is obviously a huge topic. There's so many different things we could be covering off in this, but when we're talking about this from a reliable web app pattern standpoint and the kinds of things to consider from a security perspective when building these enterprise applications, what have we got in store for you? Well, in terms of security, there's a number of different things that we can touch on, and we're going to be focusing more on the infrastructure side of the security and how we can have our application leverage some of those sorts of things. But we want to focus around confidentiality, integrity, and the availability of the resources that we're deploying into Azure. We want to make sure that the things we've got there are not going to be susceptible to malicious actors that may be providing a distributed denial of service or DDoS attack against our infrastructure. And this is one of the advantages the cloud can give us. Because we've got that scalability and that resource resilience layers that come with having these data centers that are managed not just for our infrastructure, but for hundreds of applications or potentially thousands of applications. We can leverage the security skill sets that are employed by the people that are managing these large-scale data centers. But that's kind of a bit of outside of our control. Instead, let's look at the things that we can do inside of our application to make sure that we are building our web applications with a security focus in mind. When it comes to Azure, the first thing to think about when building our security model and the way that we manage the communication between the multiple resources that we've got is to leverage managed identity. So in Azure, a managed identity is a way that we can create a connection, like you would do with kind of connection strings to a database and things like that. But rather than having to pass these credentials around between resources, like our app service might have a connection string embedded in it or something like that, we can use a managed identity to manage the connections in a passwordless manner between services. So a managed identity is something that we get out of Azure Active Directory, or should I say Microsoft Entra ID now, as it's recently been renamed. That's a bit more of a mouthful. I'm probably still going to call it Azure AD for at least the foreseeable future. But let's say that we want to have managed identity used, and for that we're going to create a identity within inside of our. I immediately went to say Azure AD, so I'm going to just say Azure AD. We're going to create an identity in Azure AD that is like it's just an identity. It could be, well, let's call it Aaron. Let's call it Aaron for the sake of simplicity today. And with that identity, well, we can apply permissions to it. We can apply our role-based access control or RBAC security to that. And it's just for that identity, which means that the permissions for that identity are available whenever we use that identity. And this means that we can also tackle things like the idea of least privilege access. So we only give that identity the permissions that it's going to need to do the things that it's going to be operating against. And because of that, we can now leverage identity-based access between our resources. So we can attach that managed identity onto a resource, and then it can use that to authenticate to other resources. It can perform operations based off of what RBAC has said that managed identity has been allowed to do. Again, this means that we can have very fine-grained permissions over the top of it, so that as we access, as we're doing communications within inside of Azure, we're not worrying about these overprivileged users having access to something. We're not just using like an SA account to a SQL database, which means that the user can go in and create new tables, delete tables, when realistically all they need is read access to data within inside of a particular database. But not everything that we're going to be working with is going to allow us to do identity-based access and identity-based authentication. Maybe we're working with some external APIs that we're bringing in, and those are going to be having their own keys and credentials for accessing them. So how do we store those in a secure manner? Because we don't have identity access that we can leverage here. Well, for that, we could leverage Azure Keyvault. So Azure Keyvault is a credential store that we can have within inside of Azure that allows us to put in credentials that we will then store securely, separate from the applications or the resources that are going to leverage those. We can then use identity-based access to define how you can access those credentials. So so this means that we can still have that least privileged access model in place. So our app service can only access the API key for an external service, or at least the app service is going to talk to that, not other app services that are within inside of our system, because we only want that available for one location. We're going to jump over to the Azure portal in a moment, and we'll have a look at how some of this is implemented with the application that we've got so far. But yes, the idea of Keyvault is that we put credentials in it. We then use identity-based access to define who can access those credentials. And then when we're doing the retrieval, so with app service, when it needs to load those credentials, it will go via the managed identity, and they get loaded the same way as like a config file, like a JSON config file off disk is done for local development. Advantage means that we don't have to rewrite the way that we do our configuration management for local development versus production, but we can leverage evolve security as we go through our local development to pre-prod to production eventually. Lastly is endpoint security. When we're thinking about traditional networking design, we're going to leverage endpoint security in the fact of creating DMZs. We're going to put something like our databases behind a DMZ, which means that it can only be accessed by certain resources within inside of our network. We want to do the same sort of thing with cloud, though. We don't want our SQL databases to be available on the public internet. And that doesn't kind of make sense, particularly in a production standpoint. And we want the way that we can restrict their access to only the resources that are needed to have access to that. And we do that using the virtual networking or the VNets within inside of Azure. Just before we jump back into the portal and the code and have a look at some of the code that we have there that implements some of these patterns, I just wanted to do a refresher with our architecture diagram. Yes, I know that it can look a little bit complex, and there's a lot of resources in play here. But the main areas of focus that we have are things such as let me actually just bring up a pen so we can draw on the screen. So we have our Keyvault instance here. Yep, that did draw, but you may be able to see a little red dot flying around. I'm not sure. It's the joys of what we have when we're presenting virtually. Anyway, so we have our Azure Keyvault there in the middle, and this Keyvault is then, as we can see, it's accessed via our private endpoints within inside of our network. So the Keyvault isn't exposing credentials externally, and then as our app service, if it wants to access this, it comes via our virtual network that then gets access into our Keyvault. Similarly with our SQL Server and our Redis cache, they are behind a virtual network, which means that they're not available to the public internet. Now, maybe in a pre-production environment, we want those available just so we can do some remote debugging and things like that. And we actually tackle this with inside of the infrastructure as code files, the bicep files that we have with inside of the repo, and the is_prod flag that we've seen in the demos in the past. Let's jump over and have a look at those in code. I'm going to start with, let's start with some of the bicep files here and have a look at that. Let's have a look at the Redis cache, for example. So inside of this, we have a deployment script that we're going to execute if the isProd flag is set to false. So if we're working with a non-production version of our infrastructure, so we've deployed it into a non-production environment, we're going to execute this deployment script, which, and if we have a look at what this is going to do, what it's going to do is take in a series of arguments, and then it's going to use the Azure REST API to enable public network access of that Redis cache. And we have a similar thing for our SQL Server because we want to have those available, like I said, in a non-production environment so that we can work with them. We can have a look what's been pushed to Redis. So, maybe we're having a caching bug. We want to have a look at that in our non-production environment rather than doing that against production. We can replicate the bug, we can inspect it, and we can do that. And from an infrastructure as code standpoint, we are just using the same infrastructure as code templates to deploy to production as we are deploying to non-production. But we're just looking at flags that we're providing into that to make sure that we enable and disable the right things. We don't want to run this script when it's deployed to production, so we'll do it that way. As I said, we have a similar thing in place for the SQL Server to make availability of the SQL database to non-production, so in non-production environments to our local developers. Now, when I talk about using managed identity, and I said that's a key aspect of a security mindset. How do we handle that when it comes to our application code? Well, what we're going to be doing here is, as we're setting up our connection to with the Azure App Server, so we're defining our configuration. What we're going to be providing is this default Azure credentials object within inside of our .NET code. Now, the default Azure credentials is going to look at the managed identity of the user that is running the application. Now, from a local development standpoint, I'm signed in with my Microsoft account. So I've authenticated against Microsoft Entra ID. There we go. I got it right this time. I knew I was going to get it right at least once. We're going to authenticate against my user profile. So I'm going to be operating with the permissions that my user profile has to work with our configuration system. But when this is deployed into Azure, it's going to use the managed identity that we've attached to the app service to then do the communication across to the app service, to the app configuration system, as well as across to Keyvault, which is where we're down here, we're configuring Keyvault. Now, the advantage of this is that from a developer standpoint, I haven't had to do like a local connection string, or I haven't had to provide a whole bunch of keys into like a JSON file or anything like that, and then have logic paths within inside of our code to say, like, if non-prod, then read keys from here, or use this other form of authentication. If production, use a managed identity. We can leverage managed identity the whole way down here. Okay. So, but the rest of it is that from a code standpoint, we're not really doing anything specific to leverage these security features. It's more what we've configured with the resources once they're deployed to Azure. So let's jump over to the Azure portal and have a look at some of this. I'm going to start with the SQL database because that's kind of like a key thing that you want to be securing. Right? We don't want our data to be exposed publicly and have malicious actors come in and retrieve that data from us. So if I come into our SQL Server, and then I'm going to come down here to the networking tab, what we've got is set up is we have the public network access. Now, because this resource stack that I've deployed is deployed in the non-production flags, we have it set up so that we have selected networks are going to be allowed to access this as long as we allow them through the firewall. Now, in the production version, we would have that set to disable. And if we come into the SQL bicep file, here it is, SQL. What the search for is prod, and we'll navigate to where is it? Oh, I think I skipped over it. Oh, hang on. Am I in the right file? There is several of these files, and if I hit the right keyboard shortcut, it would work, but no. Here we go. SQL admin for this server. this I have gone off script from what I was originally planning in the demo, but I will park that there. You can trust me that, and you can go have a look at the bicep files yourself afterwards if you want. When it's in production, we'll set this public network access to disabled. Actually, it's in a shell script. My bad. That's where it wasn't in the bicep files. I will set that to disabled, but in the non-production version environments, it's set to this to selected networks. Now I can add my my IP address here if I want to be able to connect to it, because right now I don't actually have the ability to sign into that. We do have an exceptions enabled here so that Azure services are allowed to access this server, provided obviously they then have a connection that they like a managed identity, or they're coming in with the connection string for that. So if I was to come through to the SQL databases and then the database that's within inside of this server, this one's that gets deployed, and then I was to say use the query editor and tried to log in using my credentials, to set that up so that it's going to try and log in using my credentials, you'll see that I can't, because my my client IP hasn't been allowed access. Now I can add this to the allow list for the service if because this is non-production, so I want to have access there. So this, and again, this is a illustration of security by least privileged access. I don't want just anyone that knows the address to the SQL server to be able to then log in here. We're going to allow list people and then remove them from the allow list as they need access, and then have their access revoked. So we can get very fine grain on those sorts of permissions. But just to also prove that we can have this accessed, if we were to come into our app service, oh, hang on a sec, I needed to grab the connection information for the database. Come to our connection string, and we'll get the server. We'll get the server and its port number. Grab those. I'll come back to, let's see, the API. So the API is going to be able to access this. And then we're going to come down to our troubleshooting. Where is that? Oh, hang on. Or was it on the front? This is where, like, you can tell this is a live demo because I've just had my brain freeze on exactly where I was going with this next bit. There was not health check, diagnostics. Oh man, like today is not going my way, is it? Diagnose and solve problems. That's the one that I was looking for. Okay, cool. I can come in here. I come into the diagnostic tools. I actually got a full night's sleep last night. This is bizarre. Maybe that's the difficulty I'm having today. And then we can use the network tracing. Oh, sorry, network connectivity and troubleshooting. And then we are going to, let's just check to see if we have a connection issue between services. So we're going to select the virtual network this one is in, that one. Ooh, I have several virtual networks there. And then we're going to be using the subnet that this app service is in. So this process will go ahead and we can then check to make sure that we've got access within inside of there. Connection issues. Cool. All right, and then so this is then going to go out and do all the checks to make sure that this has access to a service that we want to have access. So I want to say, just make sure that you've got access to our SQL server. So I give it the address to the SQL database and then the port number that I want to check that we've got access to, and it should go out there and check to illustrate. Yep. So it says that. It resolved at the following location. So it was routed to a VNet. So we're able to access that, even though that I personally can't log into the SQL server. We're able to access this from our app service. Okay, cool. So that's and that's sort of how we can set up we use virtual networking to restrict access between parts of our infrastructure. The other thing I want to just illustrate is our Keyvault. So I've come to the Keyvault resource that got deployed here. And we'll see that if we have a look at the access control, we'll see that we have the role assignments. No, sorry. App service. Come back to the app service. Oh, front door. Clicking around all the wrong spots today. Here we go. Okay. Now we have a user in here. No, not check my access. Okay, here we go. Here is our managed identity. There we go. That is the managed identity that has been defined for this deployed resource. It's web and then a random string identity. So this one has been given the role of app configuration data reader. And we can come in to have a look at this this managed identity. We can see it's part of the enterprise application. I've just got some masking turned on so you can't see my credentials and things like that. But we can then see what we can have a look at what this user has been provided with access to. We saw back here when we looked at the role assignments, they were provided with the app configuration data reader. What that means is that if we were to come to that, the app configuration, which is, where is our app configuration? Here it is. We can have a look at the roles that are available for this particular service. So there are a lot of different roles that a service can have available to it, and a lot of different roles that someone can be assigned to. The user that we're using in our managed identity has app configuration data reader, which means that they only have read access to it. They could be made an owner or even an administrator, depending on what that service is going to need to be doing. But in this case, because they only need to be able to read keys, they're not going to be creating new keys or anything like that. We've given them a minimal permissioned application, a minimum permission set using our RBAC rules of data reader. And we can see that the configuration that we have in here, and we can see that there's some configurations that are available, such as this the Redis cache connection string. That is then being a little icon, which I know is not particularly visible. So let's zoom in super crazy. Whoa, there's this tiny little icon here. And that's indicating that this has come from an Azure Keyvault. So this configuration is being provided by Keyvault. Because we've got read permissions set to this, we're coming in and we're able to get that. It's then getting flowed up via Keyvault, and our authenticated managed identity is going to be able to perform the operations that we're expecting that it can be performed. I'm just thinking, I think from a security standpoint, that's kind of the key aspects that we've got here. We've seen that our SQL database is only accessible when we have an allow list that's been defined. We have by default defined the Azure resources are going to be allowed access to it. We then rely on a managed identity to have access to that. And we saw that while from my machine can't access it even via the portal because my IP address hasn't been added to the allow list, the application that needs to have access to it, so this API application, it's able to connect to it by the managed identity that it has provided to it. We've seen managed identity. We actually have multiple managed identities. You can see here. So if we just sort that by type, we come down here, we'll see that we actually have two different managed identities in there, and that via those managed identities, then we have different permissions set with inside of our RBAC rules. The web one has access to our app configuration, which then flows on credentials out of our Keyvault, meaning that we have, and that's only done in a read mode, so that we have a minimal set of permissions made available to the users and to the identities that are working with inside of our application. So It's a short, sharp one today because as security is obviously really critically important in the way that we're building applications. And from a reliable web app standpoint, we can implement this by leveraging the infrastructure as code components of our application. We're able to, we saw we had some flags in there to disable and enable different things as it gets deployed. If you want to have a bit more of a dig into some of the bicep files and the script files that we use to deploy this application, do grab a copy of it from the GitHub repo at aka.ms/EAP, Enterprise Application Patterns, /RWA, Reliable Web Apps, /.NET. Have a look at the files. You can deploy them yourselves using the Azure Developer CLI. We covered that off in the first episode of this series a couple of weeks ago. But yeah, that's all I've got to cover today around the topic of security in reliable web apps. We've got 2 more episodes upcoming in this series. Next week, we have operational excellence. And then in 2 weeks' time, we're going to be talking about performance efficiency. So do join up. The links up there on the stream. Join us for the next 2 episodes. Hope to see you then. If you've got any questions, feel free to pop them in the chat. I'll be around for a couple more minutes. Otherwise, enjoy the rest of your day.